In this video, I want to talk about transforming the graph of a function by shrinking or stretching. So we've talked about a bunch of different ways to transform graphs. We've translated them, which means moving them up, down, right, or left. We've reflected them, which means flipping them over one of the axes, x-axis or y-axis. Now I want to shrink and stretch the graphs. So when we shrink or stretch a graph vertically, it looks like a times f of x. So we take some number a and we multiply by f of x, and that means that we stretch the graph vertically by a factor of a. So in this case, it would mean that we're stretching it vertically by a factor of 2, which means that we're taking everything vertical and we're multiplying it by 2. So for example, this point is 0, 3. So the vertical aspect of that gets stretched by 2 by doubling it, so it becomes 0, 6. This point is 2, 3. So the vertical aspect becomes 2, 6. So that's that part. And then this point here, 1, 2, 3, 4, 1, 2, 3, 4, 5. This is going to become 10 vertically. So 1, 2, 3, 1, 2, 3, 4, 5, and we're just going to kind of have to use our imaginations here. And so that is what this is going to look like when it gets stretched vertically by a factor of 2. Now, a horizontal stretch works a little bit differently. So you might remember that when we do a horizontal translation, everything is the opposite of what you think it would be. Well, the same thing is true for shrinking and stretching. So f of 1 over b times x stretches the graph horizontally by a factor of b. So again, in a horizontal instance, everything is going to work backwards of how you would think it would work. So for 2, this is actually, so we have to think about the reciprocal or the fraction flipped upside down. This is actually shrinking it by a factor of 2 instead of stretching it by a factor of 2, or it's stretching it by a factor of 1/2. So the factor here is 1/2 because it's the reciprocal of the number that's being multiplied. So 1 over b, if it was 1/2, then we would stretch it by 2. But it's 2, so we're going to stretch it by 1/2 or shrink it by 2. So it's the reciprocal of what you would think it would be whenever it's inside, when it's with the x. So x is kind of always backwards of what we would think it would be. So the factor here is going to be 1/2. So that means that for the x coordinates, we're going to take them by a half. So this is going to stay the same because it's 0, right? It's 0, 3. The x coordinate is 0. In this point, the x coordinate is 2, right? It's 2, 3. So 2, 3 becomes 1, 3. So we're going to put it over here. And then this point over here is 4, 5. So the 5 is going to stay the same, but the 4 is, so this is 4, 5, and that becomes 2, 5, because we shrink this by a factor of 2, or we multiply it by 1/2. Okay, so this is how we shrink and stretch graphs. So a horizontal stretch would look like f of 1 over something x, or some fraction of x would stretch it wider. A number in here, a whole number in here, makes it, compresses it, it shrinks it. But then, so it's opposite of what you would think it would be. For the vertical, it's exactly what you would think it would be. 2 times f of x just doubles all the y values. It makes everything double of what it originally was. So that's how we shrink and stretch graphs and transform them using shrinking and stretching. Or this is also sometimes called dilation.